All right, having given you this long-winded introduction to what we're trying to do, let's do it. Okay. So what we're going to see is something that is going to be with the sound very abstract. Just bear with it and realize that it is going to sound uncomfortable and confusing, and you'll just have to practice with it and play with it until it becomes more familiar to you. Okay, but it is not a bad alien; it's a friendly alien. Okay. So a vector space consists of a number of things. In order to have a vector space, first of all, we need a set of objects, okay, which we're going to denote by V for vector space. Okay, you can use whatever letter you want, but I will commonly use V. Sometimes we use a strange font to denote the fact that this is a set as opposed to a single object. Okay, but this set is going to be consisting of objects, and I'm not going to specify what objects. We're going to see later on that that's what makes this idea so powerful, that we can play with these ideas no matter what the objects are. We're going to call them vectors, but they're not going to be the usual vectors. We're just going to call these objects vectors. Okay. Then we're going to need two operations, okay? Two operations that are going to link these objects. Okay, what are these two operations? The first operation is an operation that will take two of these objects, so say an object v1 and an object v2, and change them into a third object v3. Not necessarily different from either one of the first two, but just another one. It can be different. Okay, we're going to call this operation an addition, even though it does not have to be an addition in the usual sense. It could be something, it could be done in a way which is quite different from a regular addition, and that's why I'm denoting it with that plus in a circle, to remind you that, well, what we're going to look for is properties similar to that of regular addition of vectors, okay, but doesn't have to be the regular addition. What it does have to do is take any two vectors and associate to them a third vector, okay? Or take these two vectors, associate the other vector, or take these other two vectors, associate the other vector. And again, what they can be, what we can associate sometimes to two vectors may be one of those two vectors itself. Okay, it doesn't have to be necessarily a separate one. We need also a second operation. And this operation is an operation that is going this time to take a scalar and a vector and multiply them together to create another vector, okay, or associate to that couple of a scalar and a vector another vector. We're going to call this a scalar product or scalar multiplication, but again, it doesn't have to be multiplication or product in the usual sense of the word, in the way that we have seen it before. What we're going to be doing, therefore, is we're going to be considering scalars, and here we're in familiar territory. By scalars, we do mean all real numbers. I've just written down a few of them there, but we're considering all real numbers, and we're going to still call them scalars. So what we're going to do this time is we're going to take one scalar, one vector, put them together, come up with a different vector. Pick another scalar, another vector, put them together, comes out with a different vector, and so on and so on, right? And once again, once we put together a scalar and a vector, we don't have necessarily to come up with a different vector. It might be the same one, and we're going to see later when that happens. Alright, so what we need is a set of objects, two operations that manipulate these objects and put them together, and we need a third thing. We need 10 basic properties that we're going to call axioms, and we're going to demand that all of these properties be satisfied in order to have a vector space. So if you have a set of objects with these two additions, but some of these axioms are not satisfied, then it's not a vector space. All of these three things have to be in place. Set of objects, two operations, 10 axioms.